All right, so yeah, I think now is as good a time as any to kick this off. So I'm Michael, co-founder of ZKPassport, my co-founder Theo.
Theo here.
And welcome to the workshop. So just a high level of what we're going to go through. I'll kind of explain what's possible with e-passports and ZKPassport, what it allows you to prove, some interesting use cases, and then we can jump into our SDK, which is going to be like a hands-on workshop with a really easy flow of basically plugging in ZKPassport, and you'll see how you can actually use it right now in the real world to be able to tap into these identity primitives and prove really interesting stuff and get these really cool properties. All right, so diving in, I'm not sure who's familiar with ZKPassport here, so I may as well just, I can give an overview of the flow here and how it works. So high level, governments around the world, they basically have these root certificates that we get from official sources in a registry, and these root country certificates, when a government will issue passports for their citizens, they will use these to sign over the data in the passport. So everyone's passport, you have an NFC chip on it, and our app allows you to scan that data into the ZKPassport app, and then we utilize ZK circuits with Noir to essentially prove those signatures are valid through the root certificate to the intermediate certificate to the passport data itself. And this uses the Brattenberg backend proving system, ASIC also made. And it's very efficient with Snarks, and that allows us to have mobile proving, which is the key part here for privacy. So other proving systems, they're way more memory intensive, and we need to minimize that when we're doing these proofs. So we have these 4 different sub-proofs that we generate. Each sub-proof is responsible for a different part of the verification process along the route. And then it's all client-side, so the privacy is intact there, and none of this sensitive data leaves the device. And then you can have this final proof at the end that allows you to have selective disclosure over, for example, like you want to maybe just prove which country you're from. You want to prove maybe something even as granular as your first name. It could be the over a certain age, over 18, over 21, even between an age range. All these different possible options you can do. And with this SDK, you can essentially request that via the TypeScript interface when you use the library. And then it generates a QR code that you can display to the user. They'll scan that QR code, and then it'll basically route them through to download the app if they haven't, or it'll open the app with a request prompt. So yeah, we can go through that process. And this is kind of what it looks like, this little video recording here of the flow. So you'll scan this MRZ region first on the passport you might have been familiar with. There's 2 bottom lines or 3 lines for a national ID. It'll use the phone's NFC reader, it'll scan it in, the passport data loads up, so you get to see a picture of yourself here. Then you'll scan a QR code like this. It'll request the credentials here, so this is like proving that you're over 18, you'll accept it. It's kind of going through really quickly here, but if you're watching the recording, you can probably pause and slow it down. And then, the proof is then sent over this end-to-end encrypted bridge, to a WebSocket bridge to the front end of the service, where they can verify that proof on the back end for Web 2 use cases. So recently we integrated with DevCon last year, but DevConnect this year to provide ticket discounts if you could prove that you're from sort of Southeast Asia or Latin America for the recent DevConnect, and you get a 50% ticket discount. So it's really wonderful seeing these integrations. And more recently, we've integrated with Aztec, the sequences. So basically, as a way to mitigate the sort of airdrop farming, when people spin up, hundreds of nodes, and essentially to maximize their, the airdrops they can get, flooding the network. This requires ZKPassport proof that's completely private. Nothing else is revealed except for this unique identifier that emerges from the proof. So that's kind of like the minimal proof that you can actually generate. And that provides this zero resistance to have it. So it's like, pretty much one person, one sequencer. Obviously, you might have 2 or 3 passports, but you're not going to have 100. There's a really strong resistance here.
Yeah. So it works both with national IDs and passport. I think, so for example, you have a national ID here, it's like a French one, so that works too. I think someone in the crowd just tried with their national ID as well.
Yeah.
How was the experience?
Good. It says
Oh, that's great to hear.
Wait, where's that one from? Which country?
Germany.
Oh, Germany, nice.
Oh. First time using ZKPassport?
It's the first time I use a digital function of the passport.
Ah.
I always thought I needed a PIN code to use it.
You need PIN code for some kind of operations, not all of them. But yeah, it's like
Code for login, for example.
yeah.
Login like that.
Yeah, because I don't know that PIN code anymore.
Some more sensitive data, like maybe fingerprints that is embedded.
I think it's for like interaction with the private key
Yeah.
in the chip. You need the PIN code.
Obviously, okay.
Yeah.
I had no idea.
A lot of cool features. Yeah.
And is it the same standard across all nations? Or?
So yeah, so if you see this little icon here,
Yeah.
this is the sign that's ICAO compliant. So this is a standard set by the International Civil Aviation Organizations, which is a subsidiary from the UN. And essentially they standardize all passports since the 90s. And now the standard is also done with national ID as well. So like in the EU, for example, it's been mandated since 2021 to do that for all national IDs. Yeah.
So if you're curious on the standard, it's ICAO 9303, and it's a massive PDF, like 50 megabytes, something like this.
Yeah, I actually read the entire thing.
I'm so sorry for the pain. I skimmed it, mostly.
It took me about
ChatGPT.
it took me about 4 days to read it. So yeah, interesting.
It's not light reading.
It's properly implemented across all countries?
Mostly. This is the kind of the issue where this is what we're currently smoothing out all the rough edges by getting people to come and help beta test. We have these errors that come up, and then we sometimes we'll reach out to the person individually because obviously it's passport data. It's very sensitive. We don't want to just have kind of analytics that would reveal that. So it's a painstaking process of more personalized bug fixing.
Yeah, it's like it follows a stand. Oh yeah, go ahead.
I also just tried it and also got the agenda wrong. It's the
Wait, what?
The gender. Wait, what?
Oh, I thought you said the gender wrong. Okay.
Wait, what do you have? What do you have in your gender?
Female.
Wait, it did get the gender wrong. Okay.
Female.
Wait, what do you have on your MRZ? Like,
Sorry, what?
on your MRZ, do you have an M or like do you have a F? Because I know there's a gender neutral thing, but I've never seen it before.
But the thing is, I think it doesn't even have a gender.
This is an interesting edge case.
There's no gender.
Do you mind if I have a quick?
I think it's only in the NFT, NFC
Yeah, I think you're right. Yeah,
data.
it is.
You don't have gender on your card.
So the passport, you'll obviously have it visible.
Okay,
but
so like
national ID is.
Because like blindly on display, it defaults to female if it doesn't find the right gender. I guess I should create a new.
Female 0, I guess.
It's like it just detects if it's. It just
We put the Thera gender first as the default.
We were using the ternary operator.
yeah, I'm gonna need to change that condition.
Busted.
And this is very interesting. So you don't have any gender.
How about
on
a
your-
question mark? If we,
I'll figure it out. Neutral, I guess.
I'll just remove the field. Yeah.
You could write a blog
That's
post.
the question. I scanned my ID and it says connect to website.
Yeah.
And then it says position the QR code inside the frame. Like what website does it mean? Like what
So let's say, like, you're gonna show the demo, but
Yeah.
like go to the browser. I think I already have opened it. It should be.
So we have demo.ZKPassport.id up. This is a really nice place to kind of get started, just to see it. And then the source code of that is available too, so you can easily spin that up yourself.
You got another question? How are outdated documents handled? Like my passport is expired.
If they're so the current date is passed in as a public input, and it'll check that it's basically not after that date. So it'll be invalid.
So it's the website that requires a proof from me. It kind of links it to the current date, and I cannot prove anything with my expired passport.
Yeah, because
So
it'll.
like my date of birth hasn't changed because my passport.
So essentially, in the circuit, we pass the current date and we verify it against the passport date, like privately. But then the website is also going to verify on their side that that date is like a
Close
recent
enough to the current date.
close enough to the current date, so it's not getting a too old proof. And after that, so because you're kind of obliged to have like a recent proof, you kind of have to regenerate it regularly. And so if your passport expires, you can't do any proof anymore. And so you.
So isn't the like? I'm just trying to figure out. So say my passport says my date of birth, and then my passport expires.
Yeah.
But my date of birth hasn't changed, and I can prove that I'm over a certain age because this information will not change ever.
Yeah.
So technically, I could prove it with an expired passport.
Yeah, but
I think Elliot, to answer my paraphrase. So you wrote that you didn't make it up. That the idea is that, when you make the proof, you pass in a date as a public input. So let's say today is 19th of June 2025. So I pass in much of the intra-verified, and then from the passport data, the ZKPassport will check that the expiry date of your passport is ahead of that date. So let's say your passport expired January 2024. So you could make a better proof where, as a public key, you pass in, say, like December 2023, but then that's a visible part of the proof. So you serve it to IT events and go, well, this proof was made against 2023 and it's 2025. So,
Yeah.
So yeah.
Not only will they verify the proof, they'll also check, like a logic check outside the proof verification, that the current date from their system clock is close enough to the public input date to the proof.
Because my question is like, if I want to check proof of age, and I accept also that, can I choose to accept expired passports if I want?
As an option.
In our current logic, we only accept non-expired documents.
That's what you're saying. Yeah. We don't have that option, but we can add that in as a flag of like ignore if it is expired, perhaps. Maybe within a range, maybe within the last 5 years, if that's what you're after. Yeah.
That question kind of is like, you measure the certificate authority.
Yeah.
Is it like similar to the AKI system that exists just to like group websites?
It is, yeah.
Is there some like company based in the US or something that issues everything eventually? And
So because
just certain countries, like, do all passports issued by
So
this country
each-
like, automatically expire?
So they're called like certificate signing authority. So each country has their own authority, and they are the root source of trust here. So each country is independent on whatever is like their passport, their national ID. They're the ones signing it.
they they issue their own root certificates, and then they'll distribute them through diplomatic channels to ICAO, the International Civil Aviation Authority, who collects them and publishes them online. And so we have an oracle that basically grabs that registry, and then we publish it. This was just announced yesterday. We just launched this registry explorer at registry.zkpassport.id. So this provides user visibility, transparency into what it means to be a valid proof. And so you can browse through all the different certificates in the system. So you can see here there's 409 root certificates of all the countries. You can filter by the signing algorithm, signature hash algorithms, or country.
Passport, so they are allowed to use RSA or CDSA, and within that they can do whatever they want. So
And this also hooks into these certificate roots. This is one of the public inputs, and this is the root of trust essentially. And this hash will represent the Merkelized country certificates. So you can also view historically here what that meant at that time. It's also published on IPFS, kind of striving to be as decentralized as possible. And
Create those roots.
yes, yeah.
Yeah.
Yeah. So yeah, this is basically just a JSON file here with all the different public keys for the RSA, ECDSA, and the different parameters of each. And this is what gets pulled in and Merkelized when you want to create like a proof, essentially.
So
with the inclusion that you're in here.
essentially, when you scan your passport, we get what we call the intermediary certificate, which is directly on the chip, that directly sign your passport data, and that was signed by those root certificates. So we ping the registry, and we fetch the certificate that corresponds to your passport intermediary certificate. So we can verify the whole chain.
Here's how the demo looks. I'll just do a quick run through the demo. This is my Australian passport. Load it in. I'll go, could be anything here, proof of name. QR code comes up. I'll scan this. This is an end-to-end encrypted WebSocket bridge.
In there. Did you scan it before?
It wasn't recognized.
Okay.
So this is me. This is me during the demo. On my phone, and then I'll press confirm. It'll prompt me on my device confirm. It'll generate the proof locally. It's going to be a lot faster this time because the first 3 subproofs are cached. The last subproof is this disclosed proof, which is much smaller, and that's the one that actually it's like a pivot proof. It just discloses, for example, just my name. That's sent back over the WebSocket bridge, where it's then verified either just in the browser here. It could be sent to a backend server, or for ZK KYC, or it could even be on-chain. So we have a cloud prover that takes those 4 subproofs and then recurses them to a single EVM proof that you can use on a chain somewhere.
Yeah. So when you scan your national ID, when you scan your passport, one thing you didn't realize is that the proof were generated straight away. Those are the base proof we mentioned. So they verify your signatures and the integrity of your data. This is done in the background, so you only need to generate those once. And then every time you do this kind of verification, we generate the final proof that disclose whatever data is asked.
So it's really nice, the UX-wise, it's just a very instant kind of
so it's
experience.
only going to take 1 or 2 seconds, tops, to generate, unless you have a lot of information required. But yeah.
So now that you've seen what ZKPassport is and how it looks and how it works, I think it's a good opportunity, good time for us to dive into how to build this.
Yeah, and so that's where the SDK enters into the fold. So integrating ZKPassport is pretty easy if you're a web developer.
Especially with the vibe coding now, it literally probably within minutes.
Yeah, you need to activate Max on your cursor if you didn't.
I've tried it. It actually navigates to the docs and figures it out, and then we'll utilize the SDK in the right way, which is impressive. This is Claude Sonnet 4 Max.
And so this is an example of our SDK. So it's made to be as simple as possible and abstract as much of the complexity that's behind all that. And it's meant to be used both in a Web 2 environment, like regular flow, fully off-chain, no on-chain stuff, or as well on-chain. So we provide both options, both flows. This is an example of a purely off-chain flows. You set up ZKPassport with your domain name. That identifies that the verification is tied to that given domain. It will actually change the unique identifier associated to your passport or a national ID, because essentially this unique identifier is scoped to your domain name and to the custom scope provided here. You don't have to provide this one, but you can provide it. So you can kind of create categories, and that will change the unique identifier. So this way, from website to website, you will not have the same unique identifier. So it cannot try to track between different websites, but you will have the same for the same website.
And this subscope here, you can almost imagine this to be a subscope. If you wanted to have polls, for example, you'd have a different identifier, a different ID for poll, a different poll, so that you can't link between the two interactions.
And so once you've configured ZKPassport on this line, you can start to build your request. So you provide the name of your service, the logo, so you have a nice logo that shows up on the access request page on the app, and a purpose, so you can explain a bit more to the users. That also shows in the app what you want to do with their data, because they have the final say. They can reject your request, so you need to explain a little bit what you're doing with that, why you're requesting this data. And then once you have done this, you can use that to build your query. Example here is a proof of age greater than or equal to 18. And you can kind of build your query. You can chain different queries, comparison of age, comparison of nationality, of issuing country.
Really nice design here with the training. So for example, instead of going .done, you could go in, and then you can have a list of countries.
If I show an example in the docs, if I can find it, I know it's open somewhere. Actually, let me just go here. Example of chaining, and that get started. Basic usage here. You're gonna have an example here. You chain multiple conditions. You want to disclose the first name. You want to check the age is greater than or equal to 18. You want to check that he is an EU citizen. So we provide some constant for clarity, for ease of use, and as well that he's not from Sweden.
Not Scandinavia in this case.
Not Scandinavian. I didn't put Norway because Norway is not part of the EU, so there's no need to check for that. So that would be an example. It's made to be as simple as possible, a very simple interface.
Will that do one group? Will all do it in one group?
So you have so we have this idea of subproof that Michael mentioned. We have different modes. So the basic mode is what we call the fast mode. That's the default one. It will reply with all the subproofs, and it's much faster. It's pretty good for Web 2 flow, because you find verifying multiple subproofs in the background because it's faster. If you want to verify it on-chain, we have this compressed mode, which actually recursively verify everything into a single proof. So this takes a bit more time because the recursion is a bit more expensive, but you do get one proof that you can verify in-chain instead of multiple subproofs.
We're working to fit and fix that, because we have cheap recursion crypto backend, but it's not explicit logging.
Yeah. Ultimately, if we get to improve, the performance gets to get improved, you can remove that fast mode and be single proof for everyone, even on the Web 2 flow. But for now, we separated it because the difference of speed is quite consequent.
And this is Ultra, Zach? That would work for Ultra, EVM?
I think got all this footage about that. It's just charging to get the API sensible, and sorry, it's a bit in the weeds, but if you use that format strip and the final proof is actually easy to verify chain as being sweet, do one layer compression, so it's not super, but we want to make it easier, for sure.
Cool. Sounds great.
So you can see an example. Here's like a web. This is the Web2 flow. You would get from the query, you call done at the end, so it finalizes the query, and you get the URL and other callbacks. So the URL, you can use it to encode into a QR code, or you can directly put a button that would open the app if it's directly on mobile. So it would, instead of like, you won't go scan a QR code if you're already on your mobile phone. And once you have this, you can also use the different callbacks. So on request receive will tell you when the user actually scanned the QR codes, they receive the request. So you can actually update your UI in consequence to what the user is doing.
So before you saw when as the QR code was scanned, it immediately detected that and showed like the prompt to the user.
Yeah,
as part
so
of the flow.
that's how essentially we updated the flow of the demo using those callbacks. It integrates the SDK directly. On generating proof, that means the user click on confirm and the proofs are being generated. And then you're gonna have the on proof generated, which you can actually get the proof if you actually need it, which might be useful for on-chain use cases where you need to get the proof and send it to your smart contract. And then you got the final result callback, which gives back the unique identifier associated to that proof, to that ID, the verified Boolean, because behind the SDK verifies everything for you. It verifies the proof, it verifies all the public inputs and the commitments. You don't have to worry about this. This verifier will tell you whether all the checks went through.
This is happening in the browser on the front end. So you wouldn't necessarily rely on this as a guarantee, but you could send it on to a backend API, for example, and then you could verify it there as well.
Yeah. So like you would this would be an example of like the interaction you would do on the client side, but you do want to use the on-proof generated callback to be able to get that proof along with the result to send it to a server if you want to verify this in a purely Web2 flow.
Or on-chain, which obviously would verify in the
on-chain flow.
Solidity verifier.
Like we have an example here where you would do that same process and then you would have a server side where you kind of pass in the query result and the proofs and then you verify it with the ZKPassport SDK on the server side, and that way you can do whatever logic you want. For example, update your database, use the unique identifier as a way to identify user uniquely.
For DevCon, what we did here was we have a database of voucher codes, and then we send that, it gets verified. The unique identifier essentially allocates a voucher, and so then if they come back and try it again, it'll see they've already been issued a voucher and it'll issue the same voucher again. So that provides like one ticket per passport. Yeah.
I guess in a Web2 context, is it really necessary to store the proof itself, or is it that
No.
this person
Like in a Web2 context, you're mostly going to want to use the unique identifier, and whenever like data has been disclosed, storing the proof is not that important. You just want to verify it before you do any kind of
before you
logic.
discard it, at least verify the proof on the back end, and then you can discard it.
The reason why you want to do it on server is like whatever logic happens on the client can be faked. So you can never trust fully like a purely client-side logic verification. You need to do some server or like on-chain.
The proof's quite small, so it wouldn't be an issue just to persist it, I think, yeah.
Let's say I have to be compliant and have to prove that I verified it.
Exactly, for KYC kind of
Do I
thing.
store, or what do I do?
The proof itself.
The proof itself.
That's irrefutable.
Authorities come and I can show them the proof and they will
Yeah.
believe me.
Exactly.
So
Well,
we'll so
that's up to the government and regulators.
So
This is
so
a
we're
new
gonna-
precedence for this.
we're going to build some kind of tools that can be used for compliance officers and authorities, so they have like a more better UI instead of like seeing like a bunch of like hexadecimal strings, because that's not going to be good for them. But like we're going to provide those kind of tools for auditing by regulators.
Could you elaborate, like, what does it mean that the verification can be tampered with by the user? Like, assuming that the user cannot fake the passport,
Now,
what can I do client side?
it's like just client side. Any logic you run on the front end, you can cheat it, because let's say the SDK verifies the proof and everything, but then the
Verified equals true. You could just put that.
it would just because it's a code that's running on the browser. All the code is going on the browser of the client.
Proof is cryptographically sound.
Yeah, it is, but it's just like I'm not talking about the proof. I'm not talking about all the logic that you build on the client side.
Like if you just sent the result of verified to a backend API,
yeah,
they could just change that to like
they
verified
could
as
just
true.
change that.
So you need to send the whole proof to a trusted backend
Because-
where you
yeah.
then verify the proof. The proof itself is, yeah.
That doesn't logical. I mean, of course, clients would like we assume the clients can tamper with the UI basically, but they cannot tamper.
That's all it is, yeah. I thought I'd just mention
No,
it.
they cannot tamper with the proof. They can only tamper with the logic you build on your front end.
I mean, otherwise, it's just the client says it's verified we trust is verified. We could just throw away all the crypto magic and
Yeah.
just trust what device.
Exactly. Yeah.
How would I test this? Can I order a bunch of dummy ID cards from different countries?
Oh, we have a feature called Dev Mode. And
yeah, we have a feature
yeah.
called Dev Mode. So if you, because some people may not have like functional IDs, or they may want to test different kind of data. So if you hold at the bottom, you will get like a little pop-up, and you can enable the Dev Mode. So this is like, you have 6 different IDs, 6 different mock passports.
Like mock characters.
With different data, different birthday, different document number, and all issued by the Zero Knowledge Republic, which is our mock
Yeah, so
country.
we've had this country just on testnet called ZKR, or the Zero Knowledge Republic. And just to clarify here, the unique identifier is always 0 for this country. So it's impossible to generate, you can generate valid proofs, but that would always have a nullifier or unique identifier of 0.
There's been set to 1 recently. So.
Sorry, to 1.
Yeah, it used to be 0, but we set to 1 because it's easier to test on-chain, because generally what you're going to do on-chain with like smart contracts is that you're going to register with the proof, and you're going to want to check that that address has already been registered.
Like a mapping
Yeah,
will
but the
always be
default
0.
value is 0.
Solidity.
So it's kind of tricky to test with 0, so we just changed that to 1, which is easier now. So yeah, actually the example for on-chain verification here, we have an entire example. And you see here the mode is like set to compressed EVM. So this is like compressed proofs, a single proof that's been optimized for EVM verification. We have another mode, compressed, which is also a single proof, but not optimized for EVM verification. Because EVM has like specific precompiles that you can use that are optimized. So that's why you need to change a few stuff.
Yeah, and then
Specific?
Huh?
Is it chain specific?
N-
Because it says EVM chain, so you.
So this is optimized for EVM in the sense that, so the cryptography behind, for Bratenberg, they use Poseidon 2, which is well optimized for ZK system, for ZK proving system, but not for EVM verification. Like Poseidon 2 is quite expensive to do on an EVM contract. So instead, when this is like a different type of proof, still Bratenberg proof, but that's optimized for EVM by essentially replacing Poseidon 2 by KCAC or KCAC 256.
So I think the question is that, is it chain specific? If I generate a proof for Ethereum Sequoia,
Yeah,
Can you not use it?
so you will here essentially when you do this.
we currently
spe-
only
you
have
spe-
a deployment on Sepolia,
yeah, no.
but we can deploy to any EVM
Yeah,
compatible chain.
for now we only have Sepolia, but like this EVM chain you specify here, it's actually going to change the unique identifier, because the scope is bound to your domain and also the chain ID as well.
Yeah.
So you can use that proof only on that given chain, because the smart contract verifier will check that as well.
To prevent,
can't be replayed, right?
Yeah,
exactly. We can't be replayed. Yeah.
So we have this specific function for like, which is pretty useful in the context of on-chain verification, which allows you to bind a user address, like Ethereum address, to the proof. This way, because if you wouldn't bind it, what will happen is that you send your proof, and then someone will just take it from the mempool and like use your proof, and then
Your proof is my proof.
my proof can't run you, essentially.
So,
Yeah.
for example, the recent like super resistance protection for the sequences with Aztec, they needed a way to bind it to an address, and this was the way that that's done.
Does binding require proving that I own the address, like signing something to try to cure that address?
No,
Or
No.
you bind
It's
it
arbitrary.
But
Yeah.
on chain, you'd verify that the message sender is whoever you bind it to.
Yeah.
Well, that could be a way too. You could, any integration you wanted at that point.
Yeah.
You would have your own Solidity contract that you'd use, and then verify the logic, and then you'd call out to our verify contract, which would return true.
Yeah, you can also bind it to custom data as well. So this is like interpreted as a string in the context of custom data. Just know that you have the SDK will check that for you, but you have up to 500 bytes of free space to use.
It's quite generous
It's quite generous. So we didn't want to push it too
in
far.
a ZK
because
context.
You got to the more bytes you have, the more expensive the proof is to generate.
You could use your password as a hardware wallet.
As a what?
As a hardware wallet.
As a hardware wallet.
Because it is signing whatever you're binding to, or is
No, it's not. It's not signing. It's
Some passports do support this
Yeah.
technology called
Oh,
active
it's binding
authentication,
the proof?
but this is a different thing. This is if you wanted to have it locked to your account, and not have someone in the mempool kind of steal that proof and then use it for their purposes.
So it's binding on the device, not on the.
It's binding it in an on-chain context where you want to have it sent to a smart contract and used for your account.
Yeah. For like if my phone gets hacked, the binding can someone else can.
Actually, that's a great question. We have another feature coming out down the road, which we're excited about.
No.
Essentially, currently it proves that you've got a valid passport, which is great, but it doesn't prove that you're the person on the passport. So we have this feature where it's basically like an encrypted face match. You can do like a face scan like this. It'll all be local on device. It'll generate a face fingerprint and liveness check from that. And then from that face fingerprint, it'll compare it against a face fingerprint vector from your passport photo. And if they're close enough, then you can basically prove that you're the same person on the passport at the time in zero knowledge. And then we have basically have like a mobile TE assumption there for that's a genuine device.
Yeah. Yeah, like some people may have wanted to try ZKML for this, but this is not necessary because you're already lowering your trust assumption to the physical hardware because you need the device to be taking the video feed. So you need to trust that. So there's no point on trying to add in ZKML here.
So if you had a higher security use case where you needed that kind of guarantee, then you could just, for example, one of the flags we'll add is this extra strength liveness check to ensure it's the person that's scanning it at the time and doing the proof. Josh?
The custom data binding, is that just a public input to the circuit?
So it's what we call a committed input. So it's like our own kind of public input. So like say it's a public input in some sense.
We call it like a parameter commitment, where it's essentially there's a public hash over arbitrary data.
Yeah.
So you can, outside of this now, check that yourself and have as much data as you want.
Yes.
And it doesn't change the interface to the proof of the circuit.
Yeah, we wanted.
It's hiding because it's a hash. Like
So-
information hiding.
Yeah, it can be. You don't have to reveal it, but you'd want to verify that the integrity holds.
So essentially, it's like allows us to have a universal interface for all the disclosure proofs. So they have all the same public parameters. So that way, whatever kind of information that's requested, we have the same interface. So we can easily plug it into the recursion circuit, the circuit that recursively verify everything. And the mobile app will actually pass along separately the committed inputs, as if they were public inputs. And then you can use those committed inputs to recalculate the parameter commitments and check if they're correct. And you can do that on-chain. Like the on-chain verifier does that verification as well, which is also why we have different kind of parameter commitment for EVM and non-EVMs, because we use Poseidon2 for non-EVM and we use SHA-256 for EVM. So yeah.
This might be like ahead of it, but like from a UI perspective, bro, like is there any way I can integrate this into my own login flows instead of like kicking them through an app or the external website, but like a widget or part of that whole process?
Not currently, but would this be a mobile app that you'd be creating?
Yeah.
So we'd have a flow where you'd be able to easily open the ZKPassport app and then it would be returned to the previous app. So the UX would be much nicer still, rather than requiring the user to do it. And maybe even like, a message that you can pass along that says return to app X.
Yeah, it's
And
like,
then a logo and stuff.
it's pretty funny because like, you would assume that would be easy to return to the app that was previously open on iOS, but it's actually not.
It's like on a Reddit link on the web. It's like, would you like to install it?
It's a nightmare. Yeah.
Open app.
They haven't solved that yet for some reason.
Yeah, just like goes to the Apple store. So yes, definitely you can use.
We'll do our best to refine that though.
How it works? So what's data is reading in order to understand your passport? There is a standard order, right? It's
For the passport?
passport standard, yeah.
Yes, there's the standard set by the ICAO, which is like the International Civil Aviation Organization. So they regulate aviation, and because they regulate aviation, they regulate travel. So you need to wait to identify yourself. So they ended up regulating passport, and then they regulated as well electronic passport. So essentially, they set the standard for the basic physical layout. There's some flexibility, and the chip and what data it has on it, and what signature algorithm it must use, what hashing algorithm it must use. So for example, it has to use RSA or CDSA. It cannot use DDSA. It cannot use initial signature. It has to use those. And it can only use the SHA-2 family or SHA-1 family of hashing algorithm. And
These are collectively called EMRTDs,
Yep.
or electronic machine readable travel documents. So e-passport, national ID.
it was deployed originally in the 90s. Malaysia was the first country that ever introduced it, and then expanding throughout the world. Like nowadays, most passports are electronic. For example, if you take the EU every single passport issue in the EU is electronic. All passport circulation in the EU are electronics because they've been like electronic since 2008. The US as well. Now it's more a matter of like actually how many people have a passport. National ID are starting to follow that standard, especially in the EU, but you also got some countries, South America, and even Africa, that follows this same standard as well. So it's pretty international for once you have like some kind of international agreement on something, which is cool. If I go forward a bit more with the on-chain verifier flow, is that you would get this function, get solidity verifier details. So the SDK will give you directly the address of the verifier for the chain you're looking for, the function name you need to call for verifying the proof, and the ABI. So you can pass that then to, for example, Veeam or Ether.js if anyone's still using that. I'm not. Shots fired. And here, for example, you would get the proof from onProof generated, and then you can use that function to get the parameters. So it will structure all the parameters for you. So you only had to pass it the proof, the scope you used, and whether you want to use dev mode. So like the ZKR passport I've shown you, you need to activate the dev mode on the SDK if you want to verify it, because by default, the SDK will refuse this proof because it's like if it's used in production, it should not use like the ZKR proof as valid proofs. And so from this, you get the verifier params, which you can directly pass to Veeam for like the parameters or the function. So for example, let's go to, that's the smart contracts. I'm going to skip to that. Here you would have example, you pass the address of the contract, ABI, the function. Here's like a specific function, register with the verifier params. Like for example, I'm going to go back to register. So like this is a simple example you would use, like a registration flow. So you would use like the parameters of the verifier. You call on ZKPassport verifier, you verify the proofs with the parameters returned by the SDK, and then that responds with whether it's a valid proof and the unique identifier. So you just make sure that's verified correctly. And then you can verify the scope as well, the domain name and your custom scope if you provided any. And then you can use some helper functions to get the different conditions you wanted to check. For example, here you can check your age proof and get back the mean age, max age, and current date, and you can check everything. And you got a bunch, like the bind proof here, for example. That's how you would do the check. So you require that the user address you get from the bound data is equal to the message sender. And that way, no one can steal your proof. Yeah, which is nice.
So just to clarify maybe a stupid question. So all this happening on chain.
Yeah, so
in
this
smart contract.
Yeah.
So if I verify my age, I send it to. So basically, I can implement a DEX that only accepts users who are older than 18 or whose first name starts with an letter C.
yeah, exactly. If you wish.
So no like server required, and the user can look at the code of the smart contract and be sure that if I fulfill the requirements, then definitely my transaction will be approved.
Precisely. Yeah, compliance, so maybe like not from a sanctioned country kind of check on a DEX would be a more suitable use case for that. And you could even obscure, well, yeah, you wouldn't even reveal your country, just that you're not from these countries. Yeah.
And this verifier contract, is it like we need a separate verifier contract for each application, or is it like one verifier contract that is?
It's like it's one for each chain, so like it's going to be the same interface for each chain.
And this hooks into the root registry where the certificate root and the circuit root live. So it's always checking against valid certificates and valid circuits.
So essentially that verifier will like communicate with the registries to kind of take care of all the logic. So you only need to care about specific function and
what matters for your application.
Verify proof.
Is like this the kind of root verifier contract is maintained by you still, or is it totally like? Can it be the case that if I want to implement my DEX with some like weird requirements, I rely on your verifier contract, but then you as potentially administrators of the contract can shut me off?
So no,
it's all open source. If you wanted to like do that, you could do that. The benefit of using this is that we constantly update and maintain the registries, and because they may change, they are changing constantly.
Yeah.
So the registers, the registries are also on chain.
Yes.
Yeah.
Yes.
It's on chain.
Update them like manually.
We have an Oracle running, currently. The idea is to harden that, get other people involved in attesting to that. The master lists that are retrieved, they are also signed by ICAO. So we're minimizing the trust assumptions basically as much as possible. And then even at some point we can have like a TE, a guarantee from that as well. But also you can actually go out and independently verify these and check they are. Like you can replay what our Oracle does and you can see clearly for yourself that they are from the official government sources.
Oh, so you can verify from the outside.
Exactly. Exactly.
But the
Yeah.
contract itself.
Well, there's a lot of steps involved in getting it. Yeah, maybe a proof at some point would make sense for that, but there's a lot of steps involved.
Yeah, you can have to deal with that.
Then you can almost have like a permissionless registry, right, where you just have anyone can submit the proof of the new certificates. Yeah.
Can user force update certificates?
No, I mean unless you crack cryptography, which quantum computers may be doing at some point.
So, like ZKML has this feature that they could allow the users to force update the DKIM registry if it's not updated.
Oh yeah. So like a permissionless way to do it.
Yeah.
Not currently, but that could be a thing we add. Yeah. Currently, you could verify that what we're saying, what our Oracle says is correct. Yeah.
What's the time delay on update?
It runs just once a day, and we've noticed there've been updates maybe every few days, and then maybe there's like a period of 3 weeks where none of the registries change, and then the upstream. Yeah.
What if I lose my ID and get a new one, and I cannot access my wallet? Yeah, like I guess that's per country, right? How fast you get to make the new route. You make the new route every day.
So this is more about the actual root certificates, the signing of valid passports, but we don't have revocation built in, if that's what you mean.
Oh, so my lost passport.
Yeah, the revocation lists, they're handled by like Interpol.
If you're talking about the registration flow on chain, is that, I don't know if I put the example here, but like the way you would go about it is that you register with a proof and an address. So that address is tied to your unique identifier, and if you lose it, you can always deregister without having a proof. You're just using your address as a proof.
Oh, that's true, yeah. Because if you still hold the access to the address, you could use that to revoke.
So we know that you already verify your address is linked to that passport, so you can just deregister with your address without having a passport, and then you would re-register with your new passport.
This is like application-specific logic that you would add in.
Yeah.
I tried with the Argentinian passport and works. I tried with the Uruguayan passport because I know. And it's not working. And I don't understand why.
The Uruguayan one?
Yeah.
I think, let me check real quick, but I'm not sure we have Uruguayan certificates. Let me just check.
Okay, you don't have all those?
Oh, we do actually. We have one from 2015.
No, we'd love to, after this, we can have a look at it if you like and figure it out.
Does it mean the ID card doesn't work?
Page
Realize it's years to fix it
It didn't?
because I have the.
I think,
I mean, why?
what error do you get?
I think the issue with the passport is it's sensitive data, so it's hard to kind of like diagnose it like publicly or anything like this. We'd like look at it privately to check whatever the fields are.
I has also got a bug.
Okay.
My game is weird.
Oh, I think I understand the issue. Yeah.
Yep.
It's fun. It's kind of funny.
It's just weird in general, or?
Yeah.
Able to verify.
So like names are accepted. So my real name is Jim.
Okay. Cool.
And then it shows up as Jim.
Falkimo. What?
Wait, could you try
This is an
to...
interesting one. So there's
This is a very edge case.
I know I think I know the issue why, but we'd love to chat later if
yeah,
you've got some time. We can have a look
try
into
again.
this. Thanks for the edge case. That's great. Yeah.
Oh, that's
Confirm.
my last.
So now Jim
is my first name.
The base proofs again.
I
Because
understand. It's
this
duplicated
means that the
the first name
commitments were
twice.
not
Yeah,
equal between the proofs, which is weird.
Jim with a space.
Okay.
Plus the UI thinks my name is Jim.
German technology, so nothing is weird.
Okay. Well, we'll definitely debug that. Yeah. Thanks, Jim. We'll check it out. Thanks, Jim.
I'm not sure it doesn't go. Uruguayan, I'm not sure. Like, we're still like going through like a lot of bugs because like there's some unexpected formatting. Some are harder to debug because obviously they depend on the passport data which we don't have access to, and for privacy reasons we can't get them.
Oh, no.
What?
I just noticed it's using the brain pool curve. We spoke about this recently. Maybe it would work. You said last week there was an issue with your like uppercase brain pool.
Oh.
So if you tried it before you fixed that bug,
Oh,
maybe it'd work now.
yes, we had an issue with the brainpool one with the mapping. So that's been fixed. Like, I think that was 2 weeks ago. I'm not sure.
Before.
Yeah. So the taking a little while. It's like you probably have like the biggest one because like the German ID card, they use our biggest circuit. Yeah, that's done. Oh, yeah. Unable to verify age.
We almost need like a bounty for helping to smash these bugs. Like
Yes.
the biggest bug gets the best
Still-
next to the bounty. Something like that.
Wait.
We have to discuss it. We haven't. It might be an idea to get, yeah, this is a pretty big bug.
Yeah.
Sorry?
But like, it wasn't able to verify the
Folio.
proofs. That's why.
I'm saying India and passports are still not supported.
Oh, they would be supported. Yeah, we haven't encountered
good.
many in the wild because they're not as
Yeah, I'm
popular.
not sure what's going on.
Many of them don't actually have the NFC chip. But as soon as India starts mincing more of those with the NFC capability, it would work.
Yeah, we'll need to debug
we
this.
have the
'cause
root
I'm not sure
certificates
what's
for
going on
India.
here.
You have.
Yeah, the
Yeah, they should be
commitment
here.
should be the same, but like now they're not the same.
Different countries have different standards. It's not
Yeah.
a universal standard, right?
No, this is universal. This is defined by ICAO.
What is?
Oh, do you have an idea what it could be?
It's like this International Civil Aviation
It's,
Authority. They make the
um,
standards and they also collect the certificates of all the countries. Yeah.
I mean,
Yeah. So we have
Could you-
one Indian.
could you go into your
two.
settings and like send some metadata?
Yeah, if you
report
if you
so we can
encounter
debug it
like an
later
Indian
on?
passport with NFC, we'd love to hear about it.
Actually, they are
Yeah.
issued out to users. So
I heard about this recently. Yeah.
Debug info, so this would be the info.
With 1 billion people, it's very expensive, right? So
Nothing
Yeah.
unusual. Don't think so.
just a matter of time, I think.
That's the metadata. So it's anonymous. And for now, I think this should be enough there.
NFC reader,
So yeah, we'll try to debug this, but
like
because I know that it works with German passport, we had like a few people being able to work with it.
So the process
I would
is
be
that
surprised if there's a
the
difference in
MRZ
national IDs.
contains essentially a key, is used to derive a key for the NFC communication. So you have to have physical access to the passport, and that's what the OCR readers do at the airport, you might see. They'll read that, and they'll be able to use that to communicate through a process called BAC, which is basic authentication. And then that prevents people from skimming and reading your pocket, basically. So
How do you, but it's still valid because it says until 33.
Yeah, that's not the issue is not the expiry date. I think it's something else because like the issue was regarding the commitments between the proof. Somehow they're not matching, which means there must be an inconsistency between the inputs of the two proofs. But I'm not sure what.
it might be almost lunchtime, hey? I think our session's probably coming to an end.
Already?
Yeah,
Oh,
right?
okay.
Roughly speaking. Well, if you have more questions, please,
actually,
we're happy to stay longer.
Let me just drop, because like we had a few more slides, but just some more. So like the docs here, if you want to access to it. And I think most importantly, if you want to try it out really quickly, we got a starter. So this shows you how to do the Web2 flow, the Web3 flow, and also how to verify in a serverless function on Next.js, because there's a bit of a configuration flow for like serverless functions, which we should be able to.
So we
to
wrote
get-
an ultra honk verifier in TypeScript recently, which allows you to basically verify it very quickly without having to require WASM modules.
Because behind the scene, our SDK is using BBJS, so Bratenberg JS to verify the proofs, but this requires WASM because behind the scene is C++ compared to WASM, but WASM doesn't work very well in a serverless function without proper configuration. So this is the only annoying thing.
TLDR, it's going to be better, DevX, faster.
Yeah.
Yeah.
So yeah,
Did anybody have any questions? No?
Yeah, I have a question.
Sure.
I see the documentation and it says there's a step that you can interfere to the place on when the verification is initiated. And the question is, can you give me a hint for NRC, like I would like come into the process of verification, the user with NFC verification. Like I have a device is NFC, so I be back with JavaScript to confirm that the user presented the specific location where he touched NFC with some hardware. Like, can you have a linear hints for that?
Well, the idea would be that the user wouldn't want to give their passport data over to a particular service. They'd want to scan it locally on their own device and then generate proofs to provide to that service so that you can have the protection of selective disclosure. Because if they just scan it with your device, you could read all the data, which is generally what we're trying, that's not a good flow for the user. So the user's own NFC chip on their phone, that's the magic there. They can scan it themselves, and then you can request any credentials you wanted. You generate a QR code. They'd instead scan that QR code. That would then contain the information to provide a prompt to the user. Would you like to share, that you're over 18 and that you're from this country? They'll accept it. The proof sent back to you, and then you can verify the proof knowing fully 100% that's a true statement. Hope that answers the question.
Looks like our turn is over.
Cool. All right. Thanks very much, guys, for attending. Appreciate it.